All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still going over our malaria functional APIs module. Let's have a look at what we went over today. Now, yesterday, you recall we left off with the compiling our model and actually running it with the history equals the net model dot fit. So I ran it overnight, and this is what I got. Now, I was supposed to run it for about 5 to 10 epics, but I didn't want to go through the whole night compiling code, so I just dropped it down to one just to get an example for us today. And this is our result here, as you can see. We have our answer here. Our output is going to be a loss of 0.0197 with a training accuracy of 0.995 with a validation loss of 1.8456 with a validation accuracy of 100%. So that's only after one training session. It would have got a lot better with even maybe three. Like I said, because of the time constraint, I just left with the one so we can actually get through it so I can have this result to show you today. As you can see, it trained for 2,290 seconds with an average of 3 seconds per step. So that was that. So here's what we get as a result. That's for this here. And now we're going to move on. We did do a lot of note taking today, and we did run a lot of other options. But let's see what we have. Now, coming back to our model, we'll see that we have a feature extraction, C lines 198 to 204. Let me show you that really quickly. So you can see here from lines 198 to 204. We have them commented out now because we're actually doing something a little in the future. So they're commented out now, but imagine them being uncommented out. So this is 198 to 204. These are our COV-Ds, our batch normalization, and our max pool 2D. So let's go back down. Okay, so these COV layers are responsible for extracting useful features from the images, and the last layers are responsible for correctly classifying whether the image is parasitic or not. See lines 208 to 216. I'll show you that really quickly. And it should be uncommon because we're about to use this in a different function here. But you see here 208 to 216. So these lines here are actually responsible for classifying what the image is, if the image is parasitic or if it's uninfected. And like I said, the first few lines up here, the cover lines, are actually the lines responsible for extracting data from the images for us. So that's why we have all of the images, or that's why we have all of the information we have. This information here actually gives us what we need to feed into this information here to actually give us our output. So image we extract information from the images using this information here, and then the image is classified using this information here and let us know whether that information was parasitic or uninfected or not. Now, I apologize if I sound kind of jumbled. It's been a long morning. We've been going back and forth. We've been commenting things out, uncommenting things out, moving things around and try different things. So it seems like it's sort of all over the place, but just bear with me. Okay, so let me go back down so we can pick up our reading. Okay, with that said, we could build a model known as a feature extractor. It will be constructed exactly the same way as we have our model constructed so far. The only difference is we will leave out the flattened layer and the dense layers. So that would be the line 208 to 216. That will be commented. I had it commented out previously to run this example, but I uncommented out for what we're doing right now. But yeah, imagine those lines commented out. The flattened layer and the dense layers are commented out. Now, instead of rewriting a whole new copy of the same code, we would just comment out lines 208 to 212 in the original code to indicate we are only using the extractor. And that's the COV-D lines. The constructor lines are the COV-D lines. The COV-D, the max pooling, and the batch normalizations. And we will also comment out line 216, which was our old output, and modify line 202 to be our new output. Let me see if I can show you that one really quickly. So yeah, this was comment out. We commented this out because we had a new output, which was going to be our. Well, we actually got rid of it because no, here it is here. We just commented out. So this is going to be our new output in that model we were running. So we turned the max 2D pool or the max pool 2D into our output. So that's why we had that commented out down here. We originally had this one commented out, and we had the max pool 2D uncommented out because we were running something. All of this was uncommented out because we were running it separately than this. All of this here was commented out because we were just running the extractor. We just wanted the extract information. We didn't want any of the classifying information for what we ran. Okay, note we must remember to modify the func output to just output in our net model function, C lines 229. Like I said, it's going to be a lot of back and forth because this we've been doing all morning, going back and forth in and out of the code, uncommenting things out, commenting things out to change everything out. So we had changed this function output to just output. As you can see, that output was connected to the output here in our Where did it go? So that output was connected here to this output. So that's why we had changed it from func output to just output to go along with this max pool 2D. We couldn't use func output because func output was connected to the dense layer. That's why we changed it in our model. That's why we changed it here. I just changed it back to func output because we're reusing the func output because we're in a new section of the code and we're doing something different. That's why I have it here. But originally it was just output. It wasn't func output. Let me see what else. We will also change the label of our model okay, so we changed the name is now. Did I change it back? Let me see here if I changed it back to 29. Oh yeah, I did change it back to the Lynette model, but I did change the name to feature extraction for something else we were doing. So then we just changed it back to the Lynette model. But imagine this was feature extraction. It was the new label of our model was feature extraction. Okay, we will also change the label of our model to the same model. Okay, feature extraction line 229. Lastly, we will change the name of our model in the summary to feature extraction model. So our models aren't called Lynette model anymore for what we were doing. We changed the names to a feature extraction model. See lines 229 to 235. That's just going to show you where the place was where it said Lynette model, and we changed it to feature extraction model. Now we will run it without the history.fit or the compile and see the results. So we didn't run the history.fit or we didn't compile it. We were just running the summary of all of that for the feature extraction. And this is our output here. So as you can see, this is our output with the feature extraction information, none of the classifying information. This is just the feature extraction information. And this is our output here. You can see we have a new output of 54 by 16. And our parameters now are 1,136. Our trainable parameters are 1,092, and our non-trainable parameters are 44. Now, as you can see, there's a big difference from the 4 million that we had when we had everything all together with the classifying information and the feature extraction information. But with just the feature extraction information, this is what we get. We get a total parameters of 1,136, total trainable parameters of 1,092, and non-trainable parameters of 44. So that's how we targeted just the training extract or just the feature extraction information that we did. And we did move forward, but I'm not going to do any of that right now. Like I said, it's been jumbled up all morning. We've been going back and forth, in and out, changing things left and right, and I don't want to get any more confused. So yeah, I finally got a handle on everything. I finally know exactly what's going where and what's doing what and why he's doing it. So I'm going to leave it like that for now. But of course, I will pick it up tomorrow, and I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.